question 1, we have a curve has an equation y equals to 2x cubed minus 4x plus 5. Then we want to find the equation of the tangent to the curve. So we want to find the equation of the tangent to the curve at the point P. So if we want to find the equation of the tangent, so we know that they would have the same gradient as the curve. So step 1, we need to find the gradient of the curve, which is dy dx. So we just need to differentiate the equation. We get 6x squared minus 4. And what point are we found? We want to find the tangent at point P. This is when x is equals to 2 and y is equals to 13. So at that point, the gradient of the curve would equals to 6 times 2 squared minus 4, which is equals to 20. Then write your answer in the form y equals mx plus c. So to find the equation of the curve, we know it's using our formula is y minus y1 equals to m x minus x1. So your y minus which your point is 13 is equals to m, your gradient 20, x minus x1, which is 2. So your y would equals to 20x minus 40 plus 13. Therefore, in the format, it's y equals to 20x minus 27. Question 2. In this question, the unit vector I and j are due east and due north respectively. So just let's do a sketch of our diagram. So north, west, east, and south. So this is our director, and we're told that I is due east. So I is due east, and J is due north. So we have a Coast Guard Station O monitors the movement of a small boat. So what I'm going to do is that I'm going to sketch an axis. So this direction is I and this direction is J. So what I thought, the coast station is at station O, so I'm just going to say this is my origin. So at 10 o'clock, the boat is at a point 4 minus 2J. Let's just label our diagram. So let's say 2, 4, 6, 8. Okay, so let's find out our point at 10 o'clock, which is 4i minus 2j. So this is go 4 across, then 2 down. So this is our point at 10 o'clock. Then at 12:45, the boat is at point minus 3i minus 5j. So minus 3i, then minus 5g, which is this point here. And we want to find the motion of the boat is modeled as that of a particle moving in a straight line at a constant speed. So part A, we want to calculate the bearing at which the boat is moving, giving your answer in degrees to 1 decimal point. So, I'm going to call this point A and this point B. So the question is asked us to find the bearing which the boat is moving. So the boat is traveling from A to B. And when we measure bearings, we start from north. So this is the angle we are interested in. So what we could do is that we could find this angle here. So what we are about to do is that we are interested in this angle here. So what we could do is that we can split the angles into a triangle. So what's the distance? So this is 3 units down, and this is 7 units. Because from -2 to -5, we have 3 units, and from 4 to -3 is 7 units. So we can work out this angle here, so this small angle here. So we have a right angle triangle here, and we can use SOHCAHTOA. So just label our side, hypotenuse, opposite and adjacent, and using SOHCAHTOA, and we know we're going to use our time. So it's going to be tan theta, which is the angle we want to find, which is this angle here, and opposite is equals to 7, and adjacent is 3. So we can find out the angle must be equals to 66.8. Then we know that we have an angle on a straight line here, which is 180. So our bearing would be 180 plus 66.8, which is equals to 246.8 degrees. Part B, we asked to calculate the speed of the boat, given your answer in kilometers per hour. So firstly, speed is distance. So part B, we know that speed is distance divided by time. So we need to find the distance of the boat traveled, and this is our hypotenuse here. So it's this distance here. So firstly, we need to find the distance that is traveled. So what's the distance is that, again, this is a Pythagoras problem. So it's 3 squared plus 7 squared is equals to 3 squared, which is 58, and the distance, which is going to be root 58. Then we need to calculate time. How long did it take from A to B, point B? So 10 o'clock to 12:45. So 12:45 minus 10 o'clock, that is 2 hours 45 minutes. And remember that if we want to divide the distance by time, that time is in 60 minutes. So this is 2 hours and 45 minutes over 60. So our time is equivalent to 2.75. To find the speed, it's distance divided by time. Just 2.77. Question 3. So firstly, we want to express 28 plus 3 and root 28 plus 3 root 175 in the form a plus b, where a and b are integers and b is as small as possible. So this is just converting roots. So first, let's look at 28. 28 can be split into 4 times 7. So the key how to convert this is that we try to get a square number from this whole number. So we can simplify it. So we have root 2 root 7. Then let's look at root 175. Again, we can take 7. So 7 times what? 7 times 25 is 175. So we have 5 root 7. So basically what we're doing here is 2 root 7 plus 3 multiplied by 5 root 7. This is equals to 2 root 7 plus 15 root 7. And therefore, to simplify it, we have 17 root 7. Part 2, we want to simplify this expression and give it into the format where c is an integer. So in other words, this question is asking you to rationalize the denominator. Okay, as we can see here, we have a difference of 2 square numbers. So we want to make the common denominator. So 5 minus root 2 multiplied by 5 plus root 2. So we have 6, 5 plus root 2 minus 3 root 2, 5 minus root 2. So a lot of you have got this first step correctly, but make sure take your time when you're expanding your bracket. So you have 6 times 5, which is 30. 6 times root 2 is plus 6 root 2. Minus 3 times 5 is minus 15 root 2. Remember here it's minus and minus. So 2 negatives becomes a plus. So it's plus 3. So root 2 multiplied by root 2 is 2. Then expanding our bottom, 5 times 5 is 25. 5 times plus root 2 is plus 5 root 2. Minus root 2 times 5 is minus 5 root 2. And root 2 times root 2 is minus 2. Then simplify our expression. So we have 30 plus the 6, it's 36. We have 6 minus 15, 6 root 2 minus 15 root 2. This is minus 9 root 2. We have 5 root 2 minus 5 root, it cancels out. 25 minus 2, which is 23. So in here we have an so we want to express 3x squared minus 9x plus 5 in the form ax plus b squared plus c. So what we have to do is we have 3x squared minus 9x plus 5. So firstly, I'm going to consider those two terms and take the common factor 3 out of the bracket. Then I'm going to complete my square for this part only. 3. So remember, we halve this term, so it becomes minus 3 over 2 squared. Then we minus this number squared, which is 9 over 4. Then we need to expand our bracket out. So we have 3 log of x minus 3 over 2 squared. Then remember, we need to multiply by 3 with 9 over 4, which is 27 over 4. Then plus 5. Simplify it, we got 3 bracket x minus 3 over 2 squared minus 7 over 4. Here states the equation of the line of symmetry. So we found our minimum point. We can use this to find our minimum point. So this is a quick sketch of the curve. So our curve is going to be looking something like this. And looking at here, we know our minimum point is when x is 3 over 2 and y is minus 7 over 4. So we want to state the equation of line of symmetry. The line of symmetry is at this point. It's this line going down here, and this is the line x equals to 3 over 2. Therefore, you must write down here line of symmetry is x equals to 3 over 2. So a lot of you have lost a mark because you have just stated the minimum point. By stating this, you won't get the point. You must write down y coordinates. So you must write the minimum y coordinate is equals to minus 7 over 4. So please make sure if it asks you to write down the y coordinate of the limit point, you must write minimum y equals to your point. So if you just write down the coordinate, you're not going to get the mark. So part 2, find the coordinates of the point where the graph intersects the axis. Give your answer in exact form. Okay, so find the coordinate of the graph where it intersects the axis. So firstly, I want to find out where it intersects the y-axis. So it intersects the y-axis. It's when x equals 0. So I'm just going to use my sketch here to demonstrate. So let's just do my axis here. So my curve is going to be it's a quadratic curve, and it's going to be looking something like this. And so what I'm interested in is where it crosses the y-axis. So it intersects y axis when x is equals to 0. So this is when x. So we're just going to substitute x equals 0 into our equation. So y is equals to 3x, 3 times 0 squared minus 9 times 0, so it's 5. So our y is going to be equals to 5. So a curve would cut through y at 5. Then I want to find out where it cuts through my x-axis. So this is when the equation 3x squared minus 9x plus 5 equals to 0. That's when it cuts through the x-axis. And I'm going to do this using my quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. So my a is equals to 3, my b is equals to minus 9, and my c is equals to 5. So minus b, which is 9, plus minus 9 squared minus 4 multiplied by 3 multiplied by 5 divided by 2 times 3. Then just type into your calculator. You should get 9 plus minus root 21 over 6. And this is approximately 2.26 or 0.736. So just looking at our curve here, so it crosses at those 2 points here. So this is a sketch of our curve. And what we're interested in is that we want to find where this is less than 0. So we're interested in this part of the curve. And this is so this point here is 9 minus root 21 over 6, and this point here is 9 plus root 21 over 6, and we're interested in this range here. So our x must be greater than 9 minus root 21 over 6 and less than 9 plus root 21 over 6. So this figure shows the design of a structure used to support a roof. So the structure consists of 4 steel beams, so AB, BD, and BC, and AD. So it's given that A to B is 12 meters, BC is 7 meters, BD is also 7, and the angle BAC is 27. So part A, we want to find to one decimal place the size of angle ACB. So ACB. So we're interested in this angle here. So looking at the diagram, this is an obtuse angle. That means this angle must be greater than 90 degrees and less than 180. So just looking at the diagram, we know this angle here must be obtuse. And this is between. It's greater than 90, but less than 180. So we can use our sine rule to find the missing angle. So for finding the missing angle, we have sine A over A equals to sine B over B equals to sine C over C. So we have A, so we have sine 27 over 7 is equals to sine C, which is the angle we want to find, over the side 12. Then rearrange our equation, we get 12 sine 27 over 7 equals to sine C, and C must equals to sine minus 1. Then type this into our calculator. We get the angle is equals to 51.1. But what we said at the start, this angle is obtuse, so it has to be between 0 and 180. So how I think about it is that I think about my sine curve. So this point here, which is 51.1, is the same as this point here. So it will be 180 take away 51.1, which is equals to 128.9 degrees. So this angle is 128.9. The steel beam can be brought in whole meter lengths. Find the minimum length of steel that needed to make the complete structure. So this means we need to find all the lengths. So we already have this length here, AB. So we need to find AB, which we know already, which is 12. We also need to, we have BD, which is 7. We have BC, which is equals to 7. And now we just need to find AD. So we are trying to find this length here. We want to find the length AD. So firstly, we need to know the angle opposite, which is this angle here. So to find out this angle here, what we can do is that we already know this angle here, which is 27. We can use our sine rule to find. If you can see, this is a big triangle here. We can use the sine rule to find this angle here first, using our sine rule. So we have sine A, which is 27 over 7, is equals to this angle here, which is sine 27 so which is sine d/12. Therefore, it's same as before. We know that this angle here is going to equals to 51.1. So we know this angle is going to be equals to 51.1 degrees. And we know triangle add to 180. So this angle here is 180 minus 51.1 minus 128.9. Sorry, I just got this slightly wrong. So this angle here, so this is triangle here, which is 27. So it's minus 51.1 minus 27, which is equals to 101.9 degrees. So we know this angle here is 101.9 degrees. Then now we can just use our cosine rule to find the missing lines. So we have a squared equals to b squared plus c squared minus 2bc cos a. So we want to find the missing lines. So it's two sides, which is 12 squared plus 7 squared minus 2 times 12 times 7 multiplied by cos, which is this angle here, which is 101.9 degrees. So a squared is equals to 227.6, and the a most equals to 15.1 meters. So let's look back. So we know AD is equals to 15.1. Now we need to add them up. So 12 plus 7 plus 7 plus 15.1, which is equals to 41.1 meters. But remember, they only can be brought in whole meters. So this it must be 42 meters.